All right. Hello, everyone. How is everybody doing tonight? For those of you that are tuned in, can you just confirm that you can hear me all right? I know I've had audio issues once or twice in the recent last couple streams, so I just want to make sure it's all good. With all that said, whoops, phone alarm. So with all that said, welcome to the stream. For those of you who are new here, we are developing a game engine from scratch on stream. This started off as a YouTube series, and initially what I did there was I sort of had a very clear-cut, like a tutorial series, clear-cut videos from, with a set start and stop point. And it's kind of evolved into a more freeform dev thing, and then eventually I switched over to doing this live stream. The reason I did that was because it makes more sense to me for you guys to also understand my thought processes in terms of decision making and whatnot while developing this. So everything we're going to do with the engine, with a few small exceptions, is going to be done here live on stream for the most part. So with that said, I do want to review quickly something from the last stream. So in the last stream, we had some dynamic library loading that we implemented for the Windows platform. And I've gone ahead off camera and actually done a implementation of that on technically Linux and Mac. And the reason I did it off camera is because my Windows machine is really the only one that's set up for streaming right now. I don't have the others set up for that just yet. I might be able to do it on the Mac before too much longer, but the Linux box is actually dual booted with this one, so that's presenting some challenges. Anyway, so basically, this change incorporates only the platform specific stuff for those two platforms. And it also brings up something that I've been kind of wanting to address for a bit anyways, in that our actual platform for Linux and Mac actually have a lot of overlap, particularly things around like mutexes. They're using like the pthread library, things like that. And a lot of that is sort of duplicated between the two. So at some point, I'm probably going to take the duplicated elements between these two and combine them into a new file that I've just created here. So what we're looking at here is a pull request that I've put in with these changes. And this is just platform_nix because macOS is Unix-like, and then you also have Linux. And this code would wind up being the same between both of them with a very small exception. So in this case, we're going to say if we are on Linux or Apple. Everything in here applies, and then really the only difference between these two is the file extension for the actual loading of the dynamic library. So on Linux, that's a .so file, and on Mac, that is a .lib file. Everything else here is the same. And most of this stuff is actually drop in with what we did on the Windows platform last time. The only difference is we are using this DLFCN, which is for dynamic libraries. And then if we look at the actual implementation itself, we have a library here. This is equivalent to load library in Windows. So we have a DL open. It's almost a direct drop-in replacement. So everything else here works the same. The unload is also almost exactly the same. The only real difference is the type that we deal with. That is, let's see, it is, where is it? DL free in here somewhere. DL, where is it? Unload. DL close, rather. This one right here. So there may be an opportunity here to actually consolidate more of this logic, but I think this is good enough for now. And then we also have the ability to load a function. Again, this is pretty much the exact same as on the Windows platform. We are just using DLSym for dynamic library symbol. and that is the equivalent to get proc address for Windows. So this is all there is to that change. And I've done this as a pull request, so it's super obvious what this change was for. So I will go back here, and I'll go ahead and merge this in now live so that you guys have access to that. And there we are. And then before I forget to do so, I will go ahead and pull that down. So we should be on the main branch. We are. All right. And we have the new change there. So let's actually get rid of the terminal for now. And what we're going to be looking at tonight is we are going to be looking at generic file watching and the ability to detect when a file has been updated and go ahead and kick off an event telling us that that file has been updated. And so similar to what we've done in the past couple videos where we've had some platform code that we have to implement, I'm going to go ahead and implement Windows code tonight live here on stream. And then I will go back and do the Nix code for this afterwards. So the way that we are going to be doing our sort of hot reloading is we are going to have a couple of files. Let me actually do a clean. And let me actually remove all of these. And we should be empty in the bin. Okay, so what we're going to do is we have these various libraries that we've built. And on Windows, those are DLL. But we also have some files that go along with that for debugging. So, for example, we have the engine DLL, and then we have some of these exp ilk files. We can ignore those, but this pdb file here is basically containing a database of debug information. And whenever we load a DLL on Windows, we also load this pdb file. And there are some issues around that we are probably going to, or at least we're going to try and tackle that tonight. But we need to figure out some sort of way to be able to hot reload these DLL files. So what we're going to do is we're going to set up the detection code first, or the detection logic, for files having been written to. So that way we have a way to say, hey, this DLL or whatever file has been updated. We need to go ahead and reload it, or load it as an asset, or what have you. And so that is sort of the next requirement in this system. And then finally, we can kind of hook up all these various pieces that we've built so far and start hot reloading the game code. Okay. One more thing that I want to point out before we jump into this is designed to be an interactive stream. So if you guys have any questions along the way, please feel free to drop them in the chat, and I will be keeping an eye on that, and I will answer them as soon as I happen to notice it. So, okay. So I think that is all the intro stuff. So let's go ahead and jump in. So I think probably the first thing that we should do is we mentioned that we wanted to sort of make an event that gets called whenever we actually have a file that has been updated. So I'm going to start there. Let's go to event H, and we'll go here to our enum rather for our event codes, and I'm just going to define a new one here towards the bottom, and I'm going to call this event code watched file written, and I'll set that to 0x18. And basically what this is going to do is whenever we watch a file, we are going to keep track of whenever a write happens to that file. And this will be tied into our sort of our platform loop, if you will, and we're going to be checking that continuously. So whenever we're watching a file, we're just going to be checking it, saying, hey, has this updated, has this updated, has this updated? And when we finally do get a, hey, this actually has updated, we're going to trigger an event. So whenever we create a watch, we are going to keep a hold of a identifier or a unique identifier for that particular watch. And that is what we are going to send along in this file written, so that we don't have to send a string along in an event. We can just use a number. And so whatever is looking out for that file or whatever is initiating the watch will also have that ID and can match up to it and look against this code and see, hey, the file we're looking for an update on has been updated. Go ahead and do the thing, whatever that thing is. All right, so I am actually going to copy this right here because this actually contains kind of a template of how I want to set this up. So we'll say an event fired when a watched file has been written to. We want this to be a U32. We'll call this watch ID. And that's going to take the data U32, the 0th index of that. And that's basically just going to be the watch ID, right? And that's all there is to that, really. So we've just, eventually we'll hook something up to watch out for this event, okay? Okay, so I guess probably the next place to start with this is probably going to wind up being the platform layer. So I'm actually going to go to platform win32.c, and I think right below where I put all the stuff for loading our dynamic library, I'm going to add a couple more functions so that we can actually detect some stuff, right? Detect some file writes. Now, before we actually determine what those functions should look like, we probably ought to go ahead and declare some data structures. So I'm going to go here actually to the top first and say type def. We want a struct. We'll call this, we're going to keep this platform specific. So I think I'm going to follow this naming convention here and say win32 file watch. Do I want to say info or just watch? I think I'll just say watch for now. All right. And so this structure is going to contain a few basic things. So we've already mentioned that we're going to have an ID. So every time we watch a new file, there's going to be a unique identifier associated with that. And then we probably ought to include the file path itself for a copy of that, just in case for some reason we need it. I'm thinking we're probably going to, so we'll say const character array, and we'll call this file path. Right? And then the last thing that we're going to want to keep is the way that we're going to detect whether a file has actually changed or not since we started watching it, is we're going to use a Windows structure called file time. And we're specifically going to look for the last write time, right? And that is going to be when the file was last written to, right? So every time we watch a file, we're basically going to create one of these. Obviously, that means that we need to have somewhere to store those things. So we have our platform state here. So right below our handle info, we're going to be adding a little bit more to this. So we're going to create a D-array of these things. Do we have D-array included? Yes, we do. Okay, so I don't need to include that. And it's basically going to be a D-array of these things. So we will call this, I guess we'll just call it watches for now, right? And so that's going to be a D-array of these things. And the way that this is going to work is we are basically going to, every time we watch a new file, we are going to iterate through this array and see if there are any empty entries into it. And an empty entry would be like if this ID is set to an invalid ID. And if there are, we'll use that slot. If there's not, we'll go ahead and push a new entry into that array, because we'll also not only be able to watch files, but we'll be able to unwatch them, which means that, you know, at some point there may be a time where we want to stop watching for a file. So we want the ability to remove it, and instead of removing it out of the array and having to shuffle memory around and all that stuff, we'll simply mark that particular watch as inactive. So that is the reason we're storing the ID here. The ID will also be used to index into this watches array. So we'll be able to basically take a look at that index, say, hey, is this ID invalid or not? And if it is not, then we know that we have data here. Okay? I hope that makes sense. Okay. So I think that is probably all we need to do for right now up here. So I guess we'll go ahead and get into the meat and potatoes of some of the functions that we're going to need. So we have our dynamic library load, unload, or load function. So right in here is where we're going to put our watch stuff. Now there is one more thing that I'm going to kind of give away here in terms of our hot reloading. And we need the ability to basically copy a file from one path to another. And thankfully, Windows does actually give us a nice, convenient function for that. So we're going to go ahead and basically just wrap that. And then we will also utilize that when we go to hot reload the DLL. All right. So we're going to call this platform copy file. And we'll go ahead and call, I guess we're going to need a constant character array source file and a constant character array destination. All right. And we are going to use, let's see, Win32 copy file. We are going to use this guy, this copy file. So what this takes is it takes a long pointer to a C string for the existing file name, and then a long pointer to a C string for the new file name. And then it also takes a Boolean fail if exists. So that is basically to say, do we want to overwrite it, yes or no? So we're going to set this function up a little bit differently than that. We don't want to say fail if exists because that's a little bit awkward. What we'll say instead is B8 overwrite if exists, right? And then we'll go ahead and use this. Let me get rid of this tab here. We'll go ahead and use this this copy file. So it returns a Boolean. So if we go down here a little bit further, we can kind of look into this a little bit. So the return value, if the function succeeds, the return value is non-zero. So we'll basically just want to, I guess we could use that as is, right? That should be sufficient. I suppose we could check it against 0 just to be explicit. So we want to say bool result equals copy file. We're going to use the A version of that, right? And we're going to say source dest, and then we are going to use the opposite of overwrite if exists. Okay, and so the reason we're flipping that is because we're sort of flipping the logic of how this Boolean works. So we want to say overwrite if exists means that we don't want to fail if it exists. Okay, so we'll do that, and then we will return result is not equal to 0. Right? And that is all there is to that. So nice and sweet and short. So the next thing that we're going to want to do is we are going to want to set up our register watch, which is basically going to be setting up a file watcher. And so this will also return a B8. And how do we want to do this? I guess we could say, do we want to say register watch? Let's go with platform watch file. And in that, we'll take a const character array called file path. And then I guess we probably want to return out that watch ID. So we'll say u32 pointer out watch ID. And basically what this is going to do is it'll check to make sure that the file actually exists, and make sure that yeah, so if the file doesn't exist, if we don't take in a pointer to this, the outWatch ID, or we don't have a file path, we should fail. So that would be the first thing. So if not file path, or not outWatch ID. Also, we should probably check the state pointer, right? So if not state pointer. Any of those are false, then we're going to return false. And then the next part of this, should we split this out into a separate function? We might want to use this more than once. So I'm going to actually split out the registration of our watch into a separate private function. I can always merge it back later if need be, but so let's go ahead and make this private by saying it's static. We will return a B8 here as well. And we're going to call this register watch. And it's going to have pretty much the same signature. And so by the time we call this guy, we probably should have already performed these checks. Although I suppose I could just check them here, actually. Yeah, that should be fine. All right, so the next thing that we'll do is we probably ought to check to see if our array actually exists. One thing that I'm going to do a little bit differently here than I've done for a lot of the other systems is we're going to actually lazy create this array, because in our end product, we might not actually have any watches whatsoever. So there's really no reason to create this if we're not going to have any watches. So it's quick and easy enough to go ahead and check to say if not state pointer watches. Then we'll say state pointer, watches equals the array create, and the type of that is going to be Win32 file watch. All right. So that will ensure that we have the array. And the next thing that we'll actually need to do is to check to see if the file exists. Now we could use our file system file exists, but the problem with that is we actually need a little bit more info from the file. So while we could do that, I am actually going to leverage some OS specific code here. And the function that we want is find first file. And this guy, I've been into this many, many times, as you can probably tell by the visited links. So this guy returns a file handle. It takes a long pointer to a file name, and then it also takes a long pointer to a find file data. And I think there should be a link in here to what that structure actually looks like. I would think. I mean, I suppose I could F12 into it once I stand it up too. I think it's Win32 find data. Oh, this is interesting. So if the path points to a symbolic link, the Win32 find data buffer contains information about the symbolic link, not the target. Which that would be an interesting caveat. I don't think it's really going to apply to us though. So I think this is the structure that we want. Win32 find data A. So we need to declare that guy first, and I'm just going to call it data. And then what was the signature for that again? I think it was just that. Yeah. And that returned at what, H module? No, it was a handle. Okay. Handle. I guess I can call this file handle. Equals find first file A. We pass along the file path. And then we're going to pass the address of data. And this is going to fill out this data structure. So this data structure contains all kinds of stuff. Contains various file attributes, creation time, last access time, last write time, file size, a couple of reserved fields. I'm not sure what those are for. But the real one that we're interested in is this file time type here that is last write time. That's the one we want to extract. So first, we need to look here at the return type. So if the function succeeds, the return value is a search handle used in subsequent call to find next file or find close. We're going to need that in a minute. In the LP, find file data parameter contains information about the first file or directory found. Okay. If it fails to locate files from the search, then return is invalid handle value. So that's actually important. It's not just 0 if it fails. So we can say if file handle equals invalid handle value, which I think is probably like -1 or something. Let me see. Whoops. Yeah, it's -1. So if the file handle is an invalid handle value, then we will go ahead and return false here, right? Because that means that the file was not found. Obviously, you cannot watch a file that doesn't exist. Okay, so we have that. We have the data extracted that we need. So we actually don't need this file handle, and it's unfortunate that we have to have a file handle in order to just kind of extract the information that we need, but that's sort of the way the cookie crumbles, right? So the next thing that we need is this find close. So this closes a search handle opened by find first file or all these other ones. So obviously that's how we opened it. It returns a Boolean and takes in a file handle. Let me just quickly check here the return value. If the function succeeds, the return value is non-zero. If the function fails, the return value is 0. We can get last error. Okay. So we'll say bool result equals find close, and we will pass it file handle. And then we'll say if result equals 0, we'll return false. I can't think of any reason why this would fail. But hey, we'll cover it anyways, right? TNT Master 58. Let's go. First stream I could catch. Awesome. Welcome. Glad to have you here. So we are in the midst of writing file watchers to sort of detect when files were last written to. And that's going to facilitate our hot reloading of our dynamic libraries. So one step closer. In fact, I think it's going to be the last step that we need before we can actually get on to writing that. So cool stuff coming. Welcome. All right, so now that we have all this, we have the data that we need to, in order to actually create the watch that we need to register. The next thing to do there is to actually do it. So we'll need to start with a U32 count, and this is going to be D array length, and that's going to be state pointer watches. Oops, what am I doing? And then we need to obviously for loop through that. So U32I equals 0, I is less than count, plus I, right? And then as we loop through these, we're basically going to take a look at the ID and see if it is an empty slot. We're basically going to check the elements of the array to see if we have an empty slot. And then if we don't, we will go ahead and create one. So the first thing we're going to want is to take a pointer to the current element. So we'll say win32 file watch. We'll call it a pointer. We'll call this W, and we'll say it is the address of state pointer watches sub I. And then we can check W ID to say, hey, if this is equal to invalid ID, then we found a free slot to use. And what that means is we can basically just update the pointer directly. So we can say W ID equals I, right? Because the index is what we are going to be using for the ID. W, we'll do file path next, equals, we're going to take a copy of the string. So we'll say string duplicate. And this is going to be file path, so that we have a copy of that. We'll say W, let's see. Oh, TNT Master, thank you for the follow. I appreciate it. All right. What are we doing? Last write time. So this is the most important bit, right? When we create this entry, we want the last write time to be stored off. So that is what we need to extract from our data that we got up here. So we'll say last write time equals data dot what is it? FT last write time. There we go. And then we'll also need to update our pointer to our outWatch ID. You know, why am I working with this not maximized? Make this a little easier for you guys to see. So we'll obviously need to dereference that. So we'll set out watch ID equal to I. So that's basically the same thing there. And that actually should be everything we need to do. So we'll go ahead and break the loop here. And then as a sanity check, down here, we will go ahead and, well, actually, yeah, if we do this, we could probably just return, honestly. We don't even need to do this. So we can return true. If we reach this section of code down here, then what that means is we've gone through all the entries that are in the array and we have not found an empty slot. So that means that we need to create one. So at this point, I guess I could just sanity check it real quick. Actually, how would I? Something we should probably also be doing. In these fail cases, we should probably be setting this out watch ID to invalid ID so that we have something to sort of check against there. Something as an additional security blanket. So here I'm going to put if out watch ID, then we're going to set the value of that to invalid ID. And I'm only checking that because this could have been triggered by that not existing. So these other places where we return false, I'm also going to go ahead and set that to invalid ID. And then down here, just as a sanity check, I can check to see if that equals invalid ID. Which I guess it wouldn't. You know what? I'm actually, instead of doing it all over the place like this, I'm going to do it right here. That's a little cleaner. So we're going to default this to invalid ID. And the only reason that we are doing it in here additionally is because we're short-circuiting this here. So we should start off with an invalid ID. If we get past this loop somehow, and it's not been set to an ID, which technically should never occur, but regardless. In fact, yeah, I don't need this check, because that won't happen. We'll go ahead and say win32 file watch rather. We can set this to W, call it W. We'll zero it out to begin with. So w.id, we're going to set that to the count that we took up here. Because we're pushing a new index to the array, we could just use the last index, or the count of that, which will be the last index of the array once we push. So we can say the ID is that w.filepath equals string duplicate file path, w.lastWriteTime equals data.ft last write time. We'll go ahead and set the out watch ID also to count, just for good measure, and then we'll call darray push. Whoops. Darray push. We're going to set that to state pointer watches, and we will push W, and then finally return true. I think we've covered everything here. So let's just add some comments here. So if no empty slot is available, create and push a new entry. Okay, so that should cover us for that. All right, so that is registering a watch. So all we should really have to do as far as our platform code is concerned is just return register watch, pass through file path, and out watch ID. Now, you could argue that I could have just implemented this whole thing right in here and done it here. The reason I didn't do that is because we may have other platform code that needs to call into this as well. And if that's the case, I'll have to forward declare this at the top, yada yada. But I would much rather just keep it separated out for right now. All right, so that's half the equation. So we have the ability to watch a file. Now we have to have the ability to unwatch a file. And of course, that also needs to return a V8. So we'll say platform unwatch file. Unwatch feels a little bit awkward to me. If you guys think of a better name for that, feel free to drop it in the chat. Const character array file path, and then u32 pointer out. Whoops, it's not going to be a pointer in this case. Actually, I don't want the path. What am I doing? At this point, I'm going to have a watch ID, so all I need is the u32 watch ID, and that should be sufficient. Ballistic, thank you so much for the follow. I appreciate it. Welcome, welcome. All right, so for the unwatch file, I think I'm going to follow the same pattern here, and I'm just going to implement sort of an internal function here to take care of that for us. I'll group it with this one. So I'll say static B8 unregister watch And this is going to just take the U32 watch ID. And then basically what we're going to do is copy a lot of this stuff up here. So let's actually copy this section here. That's sort of our sanity check. We don't have a file path, so we don't need to check that. We don't also need to check watch ID. So actually, if we don't have a state pointer, that's the only thing that's going to cause us to boot out there. The next thing we need to do is go through everything in the state pointer. So we're actually going to copy this loop, but we're going to change the guts of it. So actually, do we even need to loop that? We don't. All I really need to do is say if count equals 0, right? Because that's, if we have nothing to watch, there's nothing to unwatch, or watch ID is greater than count. Should that be greater than or greater than or equal to? I'll say greater than for right now. That should actually be count minus 1. Just to make that a little bit more clear. So if our array is empty, oh, you know what? I'm going to have to wrap this whole thing actually in watches because this might not exist either. So we should say here, if not state pointer or not state pointer watches, right? Because this means that we have 0 watches. So we get the count of that. If the count is 0 or the watch ID is greater than the number of watches we have, then that's also a fail. So we'll return false there. Let's see. So I guess the next part of this is going to be just to index directly into the entry. So I guess what I can do is I could just say win32 file watch equals the address of state pointer watches sub watch ID. So that should be nice and fast. And then I will set the W ID to invalid ID, which, if you don't recall, that's just basically max int 32. I should probably go ahead and grab the string length of the name. So U32 length equals string length, and then W file path, and then we'll call K free. The block will be W file path. The size will be size of character times length plus 1 for the null terminator, and the memory tag will be string. All right, so we'll free that. We'll set W file path equal to 0, just to be absolutely clear that there's nothing there. And the last write time is actually a structure, I believe. Yes. So there's a high and a low. I really don't know why they did it this way. I should probably look into that sometime. I don't really understand why they have this structured that way, but I digress. It's probably some legacy thing. Okay. So I guess probably the next thing we should look at is zeroing this out. So we'll say K0 memory. The block we want to zero out is that. We'll say size of file time. And that will be zeroed out. And I think that's actually, everything that we need to do in there, other than return true. What doesn't this like? Why are you bleating at me? Just build this real quick. What did I type stupid here? Oh. It wants me to say it's a void pointer. Sure, it's a void pointer. It's probably going to want the same thing for here as well. I'm guessing. Oh, that probably needs to be the address of that. Yep, okay. All right, so here we basically just free up the entry for use. So this is sort of how we wind up with free entries within that array, right? So that's how we unregister that. And obviously all we're going to do here is a return unregister watch ID. All right. So there is that. I guess the next thing to do is probably going to be the update loop. So we have these structures set up to say, hey, we're watching these files, but we don't actually have anything hooked up to sort of check on them, right? Because we have to sort of continuously check the file time on each of these watches to see if they've been updated. So before we can actually do any of that, let's go to the top. And Jesse, thank you for the follow. I appreciate that. Welcome. Welcome, welcome. This is an interactive stream, by the way. We are developing a game engine on stream. Right now I'm implementing a file watch system, which is a precursor to being able to hot reload DLLs / our game code. So that's kind of what we're doing in the middle here. So if you have any questions or comments, anything like that, we will gladly answer them in the chat. Okay. All right. Oh wow. What is that? Me born NECA? I'm not me born. I'll go with me born. Thank you so much for the sub, the Prime sub. I really appreciate the support there. Thank you for that. I hope I didn't pronounce that too terribly. Oh, it's Kay from Discord. Hey, good to see you. Good to see you. Jesse, let's see. Hey, I'm new to coding, and it would probably sound dumb, but I started with Roblox. Lol, any tips for getting into stuff like C# and coding your own game? Yeah, so the first thing I would say is try to pick what you want to make. Like, do you want to make games or do you want to make a game engine? And that will heavily influence what you need to learn. So, making a game is multifaceted. There's the development aspect, which is what we're doing here on this stream. And obviously there's graphics, there's sound, there's all kinds of world building and stuff you have to do. So the thing I would say there is try all of it basically at some point and decide what you like to do. If the programming is the way you want to go, which kind of sounds like it might be because you're talking about C#. A decent place to start might be with Unity, since that uses C#. It's a pretty relatively easy game engine to sort of get started with. And if you decide that you really want to understand the tech behind that and the way that things work under the hood, that's when you sort of get into game engine development, which is what we're doing here. We are eventually going to be making a game using this as well. But we are using C here as opposed to C#. So really, it really makes a difference in what you want to work with. So I do know that Unity uses C#. So if you're interested in using C#, you might want to go that way. If you want to learn C and C++, Unreal uses C++. So that's probably a direction you might want to go there. Or like I said, if you want to learn how to roll your own, you can certainly follow along with this series. My YouTube channel, I think, has, I want to say, almost 90 videos in this series alone queued up. So I would definitely suggest having a look at that to see if that's something you want to do. I hope that answers your question. Anyway, let's see. What do you think would be the best starter language? I have a very basic understanding of Lua. So Lua is a perfectly fine starting language. There are some game engines that use Lua as well. I'm trying to think of one off the top of my head. I think Game Maker uses Lua, if I remember correctly. I've never used Game Maker directly, but that's also a very popular engine. You may want to look into that as well. So if Lua is what you understand, I would probably start there and get really good with it, get comfortable with it. And once you have a really solid understanding of Lua, then maybe try to branch out and learn other languages as well. Learning the first language and getting familiar with how all of that stuff works is generally the hardest thing to overcome. Once you have gotten past that sort of hurdle, then it's a lot easier to pick up others. So if Lua is what you're comfortable with, then I would say, well, I use comfort lightly because you're saying it's a very basic understanding, but regardless, if you've used it, definitely look into game engines that use Lua. I think Game Maker, you know what, I could just look it up real quick. I think Game Maker uses Lua. I think. Let's see. So this is Game Maker that I'm talking about. Let's see all features. Where does it say on here? Does it say anywhere on here? Where? Might be on this. Let's see. GML code or GML visual. I'm not sure, to be completely honest. I know there are game engines out there that use Lua. Wicked Engine. Yeah, Wicked Engine is another one. Yeah, I always forget about that one for some reason. Who knows? Maybe if Kohi takes off and it gets a wide user base, maybe there will be a Lua plugin one day. Who knows? I probably won't be the one to make it. It'll probably be somebody in the community, but I'm not eliminating it as a possibility. Okay, cool. So what we need to, just jumping back into the code real quick. Well, actually, so why did you choose C instead of C++ for the Kohi game engine? Honestly, language simplicity. C++ has become super bloated, in my opinion. And again, I should say that's my opinion. I think a lot of people will probably agree with me, but I like the sort of bare bones, simplicity that C gives you over C++. I think that a lot of features that C++ gives you can tend to sort of mask away a lot of complexity that's there that could be sometimes hard to follow or debug. And honestly, C also compiles a hell of a lot faster too. There's a bunch of reasons, really. I've always kind of, anytime I've used C++, I've always kind of written it in like a C style anyways. I don't really use object-oriented programming all that much, so that's sort of the main thing that C++ gives you over C. So I don't use that all that much. And then I guess there's also the fact that I probably wouldn't use most of the there's like maybe 2 or 3 features I can think of in C++ that I actually want to use. And that might be like maybe function overloads and maybe operator overloads. But anything like templates or stuff like that or the STL, I have no interest in using that kind of stuff. I do use some of the standard libraries in this project right now, but I'm eventually going to swap all those things out. I hope that answers your question. Okay. So I'm going to go back to programming for a little bit, and then we'll jump back into any questions if you guys have them. Cool. Yep, no problem. All right. So what we need is an update loop to basically go over all of the various watches that we have. Excuse me. All the various watches that we have, and check them to see if the file time has actually changed. So I'm going to go ahead and put that here. I'm going to forward declare it because we are actually going to need to call this further up in our platform code than where it's going to be defined. So I'm going to say no return type, and then platform update watches. Not 100% sold on that name, but oops. That's what I'm going to go with for now. Oops. So I'm going to take that and go back down here to where we were. And I guess I'll put it right at the end here. And we'll go ahead and fill this out. So obviously, if we don't have the state pointer, then we need to return. Otherwise, if we don't have the state pointer, why are you not? Oh, because I have an invalid token there. If we don't have the watches array, like there's no entries in it, then we're obviously going to short circuit there as well. So all we need to do is obtain a count and loop through these. So I'm actually just going to, instead of retyping this, I'm just going to do this. Right. And we're basically going to loop through each one of these. So we have a win32 file watch. We're going to take a pointer to this for convenience sake. We'll say that's the address of state pointer watches sub I. And we'll say if f ID is not equal to invalid ID, right? Then that means that we actually have a valid entry here. So all we're going to basically want to do is we're going to want to again obtain the information or the data from that file to get the sort of timestamp on it. So to do that, I'm going to grab this section of code here, and this is kind of indicating to me that I might need to actually separate this out into a separate function, but for right now I'll leave it as is. Paste it here. So we're going to get the data. The only thing is we don't have a file path that's passed in, but we do store that on each one of these watches. So that is going to be f file path, right? Because we did store a copy of that. So we'll just use the find first file again to obtain the find data. We'll go ahead and close that out just to make sure that we have what we need. These are returning false, but that's not a Boolean here, so I'm actually going to turn these into continues, right? Because if we have some sort of issue here, we don't want to stop the entire loop from processing the rest of the watches, right? We'll just kind of say, okay, well, there's some sort of issue here. Move on to the next entry. We may want to add some telemetry to that at some point if it actually becomes an issue, but I kind of doubt it's going to be. I guess we probably, one thing I can think of that might happen here is if the file doesn't actually exist, then that does technically count as an update, but it counts as a non-existing update, which is interesting. We should probably treat that as a separate event. Yes. So event code watched file deleted 0x19. And this is basically going to look the same. has been removed. Right, and this will allow us to handle deletes. So that's actually, it's kind of a good thing to think about. So I think if the file is not found, I think this is probably where we're going to want to put that. And then we may actually want to unwatch that file at that point. So I'm going to say event context. We'll start that out, zero it out. Context dot data dot u32 sub 0 equals, and we'll call this FID. Set that to FID rather. And then we'll say event fire event code watched file deleted. Sender, we're not going to bother with that, and we'll send the context. And then might as well just call unregister watch and send FID. Right. So in this case, this means the file has been deleted. Remove from watch. And I'm actually going to log this. File watch ID has been removed. Right? FID. Just so that we catch this in case we actually run into that. All right? All right. Let's see. Tireless Pari, thank you for the follow. I appreciate it. Appreciate the support and welcome. C lets you really understand the lowest level without getting it to the assembly level. That's absolutely true. While some things are harder to implement without the C++ stdlib, dynamic arrays are one of those things. For me, the swap to C was just so much more intuitive and straightforward. Yeah, I agree. Probably back to the language bloat Travis described, modern C++, that all the books had pushed, never clicked for me. Yeah, I kind of feel the same way. Like a lot of that stuff, I just felt like it was just overly complicated, especially when you start looking at template code. Some of that stuff gets super verbose. One of the examples I always use is the Chrono library. That's pretty terrible. Okay. So this handles deletes. This find close, I'm not really going to worry about handling. Otherwise, we have retrieved the data. So at this point, we should check the file time to see if it has been changed. And update notify if so. So the function that we're going to want to use for that, let me just bring this back here, is compare file time, I think it was. Yes, okay. So compare file time. So basically this takes in 2 file times and returns one of these. So if they're 0, that means they're equal. If they're not 0, then that means one is newer than the other. We don't really care whether it's newer or older or whatever. All we really care about is that it's either equal to 0 or not. So we'll use compare file time. So we'll say if compare file time. And the first file time we're going to use is, let's see, it wants a long pointer to the file time. I wonder why. I guess so it doesn't have to copy the data. So we'll use the address of data. What is it? FT last write time. And then we're also going to use the address of, what was it? F last write time. So if those things are not equal to 0, then we do have an update. And that is basically where we're going to update the f last write time to equal, this data last write time. And then we'll go ahead and notify listeners. Okay, so event context, and then context.data.u32 sub 0 equals f id. And then event fire, and we will say event code watched file written. The sender we're not going to bother with. The context will just be context. And that should be it, right? So anytime this is changed for any of our files, it's going to go ahead and notify. So this means that this code will wind up working with any type of file. It's not bound to like a specific type of file, like our DLLs or whatever. We can watch any type of file with this, which will be definitely useful when we start talking about asset hot reloading, which is going to be another thing that's coming relatively soon. So we can leverage the same code for that. The only other thing we need to do is plug this in to our update. And I think that's actually going to be somewhere up here. It's actually in pump messages. So in pump messages, we're doing our message loop. And then right after our message loop is right where I'm going to call this. So platform update watches, right? Because this gets called on every frame by the engine. So this is automatically just going to hook into that, and then we can just watch our frames or watch our files on every frame for updates. Okay, so that is everything that we need to do for our basic setup here. I guess we can jump into the application, which is our test bed. And in this case, I'm going to do this. I'm not going to do this in game code, aka our dynamic library that we're loading here. I'm actually going to do it at this level because we're going to test this out using a simple text file first. Because I think that's probably the best way to test this, and then have that be separate from the dynamic library load code. But I'm going to do it here because we're also going to basically put a file watch on the game library itself eventually. So all we'll have to do is change over the code to do that instead afterwards. So I'm going to test this with a text file. All right. So I guess the first thing I'll need to do is go to event, and I'm going to just copy this function signature. That way I don't have to retype it all out. So an entry C, right here at the top, I'm going to go ahead and declare my function here. So I'm going to call this watched file updated. We do not have event, so we need to include that as well. Include core event. Put that up there. All right. We're going to return false from this, only because we want other things to be able to handle this event too, so we don't want to mark it as handled. And all we're going to do, I think for right now, is verify that the code is what we think it is. So if the code equals to event code watched file, whoops, I don't want deleted, I want written, right? So that's the one we're going to listen to, at least for right now. So if the code is watched file written, We'll go ahead and k info watched file ID. We'll output the ID and we'll say updated. And I think that's probably all we need to do, except include the ID. So that's going to be, let's call this context. So context.data.u32 sub 0, which I believe is what this was using. Yes. Okay, so that's the watch ID. And so we've got our callback here. So all we'll need to do is come down here. We can place this anywhere. It doesn't really matter, I guess. It's temporary code. Oh, you know what, though? This is going to be problematic because this is all in create application, which is created very, very early on in the main. It's like the first thing that we actually do before we even engine create or stand up any of the systems or anything, which is problematic because we're not actually going to be able to listen for the event yet because none of that stuff is stood up at this point. And this brings up something that we probably need to address. I was going to wait on this, but actually we can't. We need to address it now. So I guess the way that we're doing this is we have this extern B8 create application, right? And this is expected to be defined elsewhere, right? And then we just sort of call into it here. That's our whole entry point that we set up. And this was, what was this? How long ago was this? 22 months ago we set that up. So we actually need to create another call into the application via an extern. And I think this is probably the only other one we'll need to do, but we basically need it after the engine create for stuff like this. And this is also going to be needed for the hot reload as well. Let's see. Bloodied, thank you so much for the follow. I appreciate that. Appreciate the support. Welcome. Okay. I want to offer a promotion of your channel. No, I'm good. That seems like something that I definitely don't need to do. So, thank you, but no thank you. All right. All right. So I guess probably the next thing to do is say extern B8. We're going to call this initialize application. Application app. Right, and this is going to be basically the same thing as this, just called after engine create, right? And this is going to allow us to handle any post engine creation stuff that we need to set up. So could not initialize application. Oh, this says application failed to create. That should be engine failed to create. Okay. Yeah. Okay, so that should be the only thing we need to do there. I'm going to copy this guy and go back to our entry C. And we're going to define it. So this is basically the extern where we're going to actually set up our stuff. And probably all of our dynamic load stuff is actually going to be moved to this eventually too. But for right now, I'm going to keep it as is. All right, so in our initialize, we're just going to return true here, first and foremost. And then we'll go ahead and event register, event code watched file written. The listener, I guess we can pass it the app as the listener. And the on event is going to be, what did we call that? Watched file updated. Right? We'll go ahead and check to see if that fails for some reason. And if we do, we'll return false. I don't see why it would, but you never know. So we'll go ahead and register for that event. So that way we have that. And then we'll need to go ahead and watch the file as well. So platform. Oh, you know what? I think I only implemented these in the C file. I did. What a dingus. Okay. I need to go to platform H. And export these. That's kind of important. So make sure that these are, whoops, marked as exported. I suppose I should probably fill this out. Watch a file at the given path. Pointer to hold the watch identifier. True on success, otherwise false. All right, and I'll just do this one too while I'm here. Stops watching the file with the given watch identifier. I guess I could have just retyped that. Watch identifier, true and success, otherwise false. All right, those are exported now. Now I should be able to say platform watch file. And what file are we going to watch? Let's do a quick test. I'm going to put under assets, I'm going to add a new file, and I'm just going to call it test.txt. We're going to watch this file as our sort of little test here. So we have to consider now when we run this, we're not going to have the benefit of the asset system, at least not at this level. So this is actually going to run out of the bin directory, which means that we're actually going to have to traverse up a directory and then go into assets and then test.txt. So our path is going to have to be .. assets test.txt. All right. And the watch ID, I'm going to stick this in app game library dot. You know what? I need a new property here. So under dynamic library, I'm actually going to extend this a little bit and add another new field, U32 watch ID. And ordinarily this won't be used unless we actually provide a watch to it, but a dynamic library is something that we probably commonly want to watch. So I think it makes sense to store that there. So now we can say watch ID. We're going to need the address of that. And then we're going to check it to see if it fails and return false if it does. All right. Wagers on whether or not this runs perfectly the first time. I don't think it's going to, but let's go ahead and build. Built successfully. That's something. Let's see. Let's run this. Oops, we got a breakpoint in here. Let's continue with that. All right. So we're up and running. And I'll come over here and take a look at our test.txt. And I'm just going to press, I'll enter some text, right? And I'm just going to save this guy. Control S. And I do not see it updating. Why not? Did we get any errors in here? I don't think we did. It's going to be something dumb. I can almost guarantee it. Platform watch file. So let's actually put a breakpoint in our update watches. Oh, interesting. That never got called. That means something with our register failed. Let's step into that, shall we? So we create the array. The file handle is fine. We are able to close it. The count is 0. So that means we come down here. We set all this data. We've got everything here that we expect, right? Yeah, the watch ID should be 0. Okay. DRA push. So that did the thing. Interesting. Did we mess up somewhere in here? So if I save this, right, save, it's not triggering. What have I missed? This is actually getting called, I believe. Let's make sure. So watched file written. Yep. So that works. Watch file. But I think we determined that this was like never getting called, didn't we? Oh. I see it. That should have an exclamation point. We want to say if not state pointer watches. Oh, I hate those. Okay. That could have potentially been a really nasty one to debug. All right, so let's just continue past all breakpoints. All right, so here we are, we're running. Go over here, save our test file, and voila, we have actually got our callback. So our code is 24, which I think is right. And there we are, watched file ID 0 updated. So every time I save this file, I'm just hitting Control S repeatedly, it is actually going ahead and updating that entry and kicking off an event saying, hey, this file has been updated, which is awesome. That is the precursor to hot reloading our game code. So we can see here, it's also showing up in our our sort of console here, which is awesome. So that is that. Let's go ahead and delete this test.txt file because we don't really need that anymore, and I don't really want that to get checked in. So the next thing that we're going to do, I guess, is we will take a quick stab at reloading our library. And I guess we'll see kind of how well this actually all works out. So to do this, we're actually going to need to modify a couple of things. So where do I begin with this? Okay, so back to sort of something that I mentioned at the very beginning of this stream. At least for Windows, whenever you generate a DLL, or an executable for that matter, if you're generating a debug build, there is this PDB file that gets exported along with it. And this contains all the debug symbols that Visual Studio actually needs to debug. Now, we are using Clang, but Visual Studio is sort of the backend that Clang uses on Windows by default. And so what that means is whenever we load up a DLL, even if that is through dynamic loading, as we're doing with our game code, we are also loading up the PDB. And what that means is anytime Windows loads up a file, and you don't sort of close the handle to that, that file is then locked. And so our application is loading the DLL, and the debugger loads the PDB. Now we have control over when the DLL gets unloaded, right? That's our sort of unload library that we have. But we don't have control over when the PDB gets unloaded. And in very old versions of Visual Studio, this used to be automatic. However, I think it's been since like 2013. That functionality has been broken, and it does not unload or unlock the PDB. So basically what we're winding up with is a situation where we would be recompiling our game code, for example, and we'd be able to compile the DLL fine, but we wouldn't be able to overwrite the PDB because it never gets unloaded. So what that means that we have to do is we have to use a little bit of a hacky solution to this. And this is based on something that Casey Muratori came up with, which is basically a system where we rename what the PDB is, and we give it a unique name every single time we build. Now, this binanery is only something that we have to do on Windows. So thankfully, it's not something we have to continue elsewhere, but unfortunately, we are going to have to make some changes to our build process to support this. So with all that said, let's go ahead and do that now so that we can at least get that portion knocked out. All right. So the first thing that we're going to need to look at actually is our version gen library. So our version gen, if you recall, is just a small utility that we wrote that takes in a major and a minor and then uses the clock's current time to generate a build and revision. And it sort of formats it this way: the major, minor, build, revision. And it uses the last 2 digits of the year and in the day of the year rather to form the build, which could be 4 or 5 digits. And then the revision is basically the number of seconds since midnight of the current day. And we can use this to give us a unique number that increments every time. We use this to sort of generate a version number for our engine. I think that's actually currently turned off, but we can actually leverage this utility to give us a unique PDB name as well. So we're going to modify this utility a little bit to take in an additional potential flag that is going to allow us to have slightly different formatting and dispense with the major and minor versions and only use this build revision bit, which is basically still unique anyways. So, I think probably the best way to do this is this case up here is actually going to have to change. So I actually want to take this usage and split it out. So I'm going to put this under a new void print use. And basically the way that this is going to work is the utility is going to take either as its first argument a major, or we're going to say a -n argument, right? And if we pass just .n, it's going to ignore this minor, and instead of trying to parse a major, it's going to basically say numbers only. And so that is what we are going to do. So we have our example code here. So it says version gen 1.3 generates something like this. So let's, let's copy this section, and then we'll say while, and we'll paste it. Version gen -n generates, we don't have the major or minor. We don't have a dot here, right? So we're just going to basically generate a number that looks like this, right? And so that is the print use. So this here is going to be print use, right? And so the next thing that we need to do is to determine whether or not we are in a numeric mode. And remember, we're not using our custom types in here, so we don't really have a Boolean unless we wanted to include std bool, but I'm not going to bother. So I'll just say we have an int, and we'll say b numeric mode equals 0 for false. Also, this should say if argc equals 2, then that means we have basically one argument. And if you recall the way that argc and argv work, so the argc is the number of arguments, and the program path itself is the first argument, so argument 0. And then this is an array of those arguments. So if we have 2, then that means we have the program plus one argument, which should be -n. So what we're going to say is if argc equals 2, then we're going to say we are in numeric mode, potentially, right? Because that's going to be the only valid use there. But then we're also going to check what the argument's value is. So we're going to say if argv, and we're going to say the first argument, right? So that's index 1, because the first one, or index 0, is technically the program itself. And then we'll check the first character of that, and we'll say if that is not equal to dash, okay? So we're going to check the first character to make sure that it's dash, and we're going to check the second character to make sure it's n. If either one of these are not true, then we are going to do our print use return 1, okay? And then a little bit after that, here we'll say else if arg c is less than 3, right? So if we land here, we definitely have to be using numeric mode, otherwise it's not valid. Otherwise here, if it's less than 3, we're going to do our print use return 1. Okay, so that validates that that we have the right format here, at least in general. If you pass like an A or something stupid here, it's still gonna bleat about it, but I'm not gonna bother with putting all that in. All right, so the next thing is we're gonna have to refactor a little bit of how this works. So the revision we're actually gonna use in both cases. So we're gonna move that up here, and we're going to set this all under a separate case. So we'll say if b numeric mode, and then we'll put this under the else for sort of the old mode or non-numeric mode, right? Also, we don't need to do this parsing unless we are in non-numeric mode rather. So we don't want to have an issue with that. So we'll move those there. And then if we are in numeric mode, then basically instead of this format, we're going to have just build rev, right? All is one thing. This is going to be the same thing. Actually, both of these are going to be the same thing, so I guess I could just do this. And then printf is going to be almost the same thing here, except major and minor are removed from the equation. So these first two are removed here, and then we remove the dot. Otherwise, it should be exactly the same. All right. So I think the next thing to do is to just build this, make sure it does the thing correctly. All right, and let's just test it real quick. So we'll say bin version gen exe, and we'll pass -n. Looks like it didn't like that for some reason. Why not? Did I miss something here? So if argc is equal to 2, we flip to numeric mode. We check these characters, we print use. Let's just debug this real quick. I'll remove these when we're done, just to see which case we're following in. Because it should be falling into this case. So we're getting a 1 here. So we are falling in here, but for some reason... Oh, I see the issue. Okay. Get rid of these. I'm not actually checking the second character here. I'm checking the first again. So copy pasta strikes again. This is why you should test your code, folks. All right. So version gen -n gives us a 23, 38th day of the year. And then, yep, so that looks correct. If we pass 1 and 3, we should get the other format as we expect. Okay, so that looks good. So that is our version gen. Let's see, how are we doing on time? All right, we're still okay. We still got about 20-ish minutes. So let's move on. I think the next thing we probably need to do is to implement this in our build script, I'm thinking. So let's go into our library makefile. We're not going to have to do this for executables. This is only for libraries because you can't obviously hot reload an executable. That would be kind of dumb. All right. So we're actually going to leverage this version logic here. And we're basically going to use something very similar. We're going to call this numeric only version for PDBs. In this case, we always want to do it, so we don't want to wrap that in any check. We don't need the ver comment. We don't need the ver file. And I'm going to call this K numeric version. I don't think we're going to have to do this for other platforms, but I'll leave it in for right now. So instead of version gen.exe major and minor, we're just going to pass -n for both of these guys. And that will give us a shell call to our utility, which will give us this numeric version. We do that, make it a little bit more readable. And then what we're going to need to do is we are going to have to use a where is it? So in our linking, here we go. We're going to have to use a custom linker option. Okay. And so basically, we're going to use some stuff here that kind of took me a while to look up because I really didn't want to do this sort of live on stream because this is super specific to the way that Clang interacts with Visual Studio's linker. Sorry about my dog making dog noises in the background, by the way, if you guys can hear that. So basically, they have this X linker flag that you can pass through. And what that does is it allows you to pass through flags to the underlying linker. And so what we're going to do here is use the PDB option. So the /PDB is something that the MSVC linker itself, or CL, recognizes to say, hey, we want to actually provide a custom name for the PDB file that we're generating. So in this case, we want to place that in the build directory, and then \assembly, right? And then we're going to add a underscore to that, and to that, we are going to put in our newly generated, where was it? It's up here. K numeric version. Right? And then, of course, we obviously need to add the .pdb. So what this is basically telling the linker is saying, no, don't call the PDB the same thing as the assembly itself, which is normally sort of the default. If you look in here, you'll see that's kind of what that is. Use the name that we supply instead. And what this is going to do is every time we build one of these libraries, it's going to give us a different PDB file with a unique name. And this is how we're going to get around the locking issue, because whenever we go to write this PDB out, we're always going to have a unique file name. If we didn't do this, basically the linking would fail because it's unable to output the PDB file. So this is a really stupid workaround, unfortunately, that we have to do, but necessary one all the same. So let's go ahead and test this. I'm just going to build. And we can see these pop in here. So we have our engine underscore, and then our sort of custom name here, PDB, and our test lib underscore name here for our PDB. So this is going to get rid of a nasty error that we would have to work around. Otherwise, this is the workaround for that, so that we can just continuously build the game library repeatedly. All right. Okay, so that is that. Let's see. We have probably about 15 minutes left on the stream. So before I move on, do any of you have any questions? And while you guys are potentially typing those, let's go ahead and I guess let's go ahead and give it a stab, right? I don't know if we're going to actually get this done in time or not, but we'll see. All right. So one potential issue that we have with our file watch system is an issue that we actually worked around with our dynamic loading, where we sort of load the DLL or SO extension, depending on what platform we're on. And this actually requires a full file path. So I'm tempted to make a platform function that will return that for us. I think that's the way I'm going to do it, because that's actually something we probably should go ahead and put in. So let's go to platform H, and we'll go here to the bottom. And we're actually going to put this right below our load function. So K API void. Do I want to do that? Yeah. Let's do const character platform dynamic library extension. Returns the file extension for the current platform. This feels like an uber cheesy way to do it, but at least it's going to be flexible for now. All right, let's put that here. And in Win32, this is going to be return .dll. Do I want to put the dot in there? Nah, I'm gonna keep the dot out of it actually. Or am I? Nah, I'll put the dot there. That's fine. Because on platforms that maybe don't have an extension, I can just return an empty string. That should be fine. All right. So really quickly, I'm also going to place this in platform Nix. Right here. And I had up here somewhere some code to actually look. Here we go. So here, I will just say return .so and return .dylib. All right, so that should cover Linux and Mac. And let's see. Yeah, now I should be able to actually go into entry. Let's call this extension equals platform dynamic library extension. So we'll go ahead and get that. We will, let's do a character array. How big do I want this to be? Let's make this, we'll call it path. Let's make it, I don't know, 260 characters. This feels like a hack, but we're just testing stuff for right now. K0 memory, path, size of character times 260, just to make sure that we're dealing with zeroed out memory there. And then we'll say string format. And this is going to take the file name dot extension. Did we say we were including the dot actually? Yeah, we are including the dot. We don't need that. So the file name is going to be, let's call it testbed lib temp, I guess. And then extension. Okay. And so this is going to build the full path for our file to actually watch. So now we're just going to pass path. And that's going to be the game library watch ID, right? So now we're actually watching that file. When we watch that file, we should also get the application passed in as the listener, right? So we should be able to come up here. If that's the code we're looking for, we will say application app equals listener inst. We'll cold cast that, right? And then we'll do a check to say if app game library watch ID, and then we will pass through the context data U32 sub 0. So we'll say if those are equal, then we're going to go ahead and do the hot reloaded. So at this point, reloading, hot reloading, game DLL. Let's see. I wonder if I can get this done in like 5 minutes. All right. So basically what we're going to have to do is if we have loaded that, the first thing that we're going to have to do is dynamic library unload, and that's going to be app game library. Need the address of that. If for some reason that fails, failed to unload game library. All right, so we need to unload that first. Then we're going to need to take a copy of the newly created file, which we're calling testbed lib temp. In fact, I'm going to copy that. So we need to say platform, copy. Oops, not copy memory. Did we not expose that? I'll bet we didn't. We did not. Let me add that right underneath the extension. Export it. Right. Copies file at source to destination, optionally overwriting. The source file path, the file path indicates if the file should be overwritten if it exists. True on success, otherwise false. All right. So we're going to copy the file. What did I say that was? Testbed lib temp. And then we'll just copy that to testbed lib. Right. So there's that. And then we do want to overwrite that if it exists. We'll check this again to see file copy failed. All right. probably boot out of these two. Okay, so we're going to copy testbed lib temp to testbed lib, which is what we're going to actually load. And then we're basically going to need to do all of this. Except this guy, because that shouldn't actually matter. Yeah. So I'm actually going to copy this and put up here. Yeah, B8. Load game lib. Instead of out application, that's going to be app. Make sure that didn't nuke it down here. Okay, so that should be fine. I don't need to call application state size. All right, so we load the library, we load up all the functions, we assign the function pointers. Return true. So in theory, that means that we should be able to comment these things out. And instead come up here and what was this? Load game lib. Right here. Passing out application. If this fails for some reason, initial game lib load failed. Right, and before we do this, we actually do need to do this copy step as well, which is right here. All right, so load game lib. Probably going to wind up swapping these two, I'm thinking, but in fact, yeah, I think I've got these backwards. So we don't want to go from temp to the lib because we're going to be building to the lib. So let's call this. Let's make this one. Let's make all of these ones, actually. Rename to testbed lib loaded. And then testbed lib temp will just be testbed lib. That way we don't have to change our build process. All right. Okay, so our watch file updated will unload the library, copy the file, and then load the game lib, passing was it the application? Yeah, it was the application. Right. Watch file updated. Yeah, so we should just be able to pass app. Game lib reload failed. return false. All right. I think those are all the steps that we need. So we basically, when we first load up the game, we copy from, let's see, the source is going to be, testbed lib. We're going to copy that to testbed lib loaded. Then we're going to load the game lib, which we should probably check to see if this, oh, right, yeah. So that loads this guy, which is test lib loaded, gets all the function pointers, signs those things. Yeah, and then we should be good. And then basically, yeah, I think we have everything in here we need. So let me build this. All right, and I'm just going to run just to make sure that we didn't break anything. Could not create application. Great. Okay, so we broke something. File copy failed. Interesting. So, why did that fail? Testbed lib. Oh, because we need the file extension for these. All right, I'm just going to plug this in here for right now just to see if this works. I'm going to do the same for here. I should be using the extension code, but I just want to see this stuff work. All right. Okay, so it definitely looks like we've got some issues here. All right, I guess we probably should debug this just to figure out what's going on here. So entry. Just make sure we built this successfully. Yeah, all those things. Okay, so create an application. That's the first thing. So we should copy a file, the testbed lib, to the testbed lib loaded. So that should be, let's just delete this real quick and see if we get a new one. And we do. So we load the game lib. Platform dynamic load. All right, that loaded the symbols if you saw that. Looks like we have pointer functions all the way here. So we have all these seem to work. Shutdown didn't work. But everything else worked. Okay. Oh, I bet I know what the issue is. Okay. All of our indices are off because this is now the last function to be loaded, not the first. So I knew that was going to bite me in the ass at some point. So let's change that to a 6. And let's decrement all these by 1. All right, let's just let this rip and see what it does. All right, looks like we had a memory copy fail somewhere. String format. Did that? Oh. It's me being an idiot again. I didn't put anything in the destination path. Okay, so the game runs. Sweet. Now I'm going to take this batch file, not the post build, the build all, and I'm going to go ahead and take this testbed lib, copy it, make a new file, build testbed.bat, testbed lib. And that's the only thing this is going to do. So now I should be able to run this. And then we should see, if I split this in half. Now why did it open in a new? Yeah, we'll split this one. That's what I really wanted. Okay. Build testbed lib.bat. So let's try this and see if it works. All right. So we are hot reloading the game DLL. However, it does look like our console write line is failing for some reason. So I think at this point, I've actually kind of gone over a little bit on the stream as far as timing goes. I do have to work in the morning, so I think this is probably a good point for me to leave off. I actually got a little bit further than I thought I was going to tonight, so this is it's really good progress though. So we're almost there. Next stream we will be hot reloading our game code for sure. So yeah, my dog is also saying he needs to go outside. So anyways, thank you guys so much for watching and following along. I really appreciate your guys' support. Do all the things as far as follow if you haven't. Check out my YouTube channel where all these things will be archived. Definitely subscribe there and like the video if you haven't already. And yeah, I will see you guys on the next stream. See ya.